Hello everyone, this is Mrs. Snook with section 8.3. So section 8.3 is on right triangle trigonometry. And what trigonometry means is the measurement of the sides of a triangle. And with trigonometry, we can relate the angles and the sides. Up until now, angles and sides were totally different. But with trig, there's a way, if you know angles, to calculate sides. If you know sides, you can calculate angles. So first up is there are three trigonometric ratios that we're going to learn. There's actually a total of 6, but these are the three big ones. Sine, which is the ratio of the opposite leg and the hypotenuse. So if you have an angle, so in this case we're going to use angle A, opposite of angle A is over here at side with the little a, and then the hypotenuse, that's the one opposite the right angle. And the way we write it is that the sine of A is going to be the opposite divided by the hypotenuse, or A over little c. Now if we go from angle B this time, so looking at angle B, go across the triangle, now opposite is little b, and your c is still the hypotenuse. So this is going to be little b over c. Cosine, that's the next one. That one is adjacent over hypotenuse. Now adjacent means next to or touching. So if I am still on angle B, adjacent is the one with little a. So this is going to be adjacent over hypotenuse. And with angle B, that's going to be B over C. And then from angle A, from here, opposite is over here, and adjacent, the one that's touching, is B. So cosine is going to be B over C. Oh, it looks like I wrote this wrong here. This is A over C. And then tangent, that's our third and last one. That one's opposite over adjacent. So from angle A, opposite is A and adjacent is B. And then from angle B, so from here, this one's opposite and A is adjacent. So B over A. An easy way to remember this is Sohcahtoa. And I want you to write Sohcahtoa at the top of your papers so that you can remember it. S for sine. We abbreviate it S-I-N, but this is pronounced sine. So S for sine, O is opposite, H is hypotenuse. So in this memory device, the first letter tells you which trig function it is, which ratio. The second letter, it tells you which one goes in the numerator, and the third letter tells you which one goes in the denominator. So look at ka, C for cosine, A is adjacent, so ADJ, H is hypotenuse, HYP. Last one, T for tangent, tan, opposite for O, and adjacent for A. Okay, so now we're going to do some practice just writing these ratios. Now, all you have to do is write the ratio. Don't do anything else, just write ratio. Man, I can't write. So I'm going with the sine of A. So starting from A, come across here. This one is opposite. Across from your right angle is your hypotenuse. And that means over here is adjacent. So if I want to do the sine of A, opposite over hypotenuse is 5/13. Cosine of A, adjacent over hypotenuse, 12/13. Tangent of A, opposite over adjacent, is 5/12. And that's all there is to it. Now we're going to do C. Angle C. Notice your hypotenuse is always the one opposite the right angle, so that doesn't have to change. But when I'm looking from C, the 12 becomes opposite and the 5 becomes adjacent. So that's going to change my ratios. Sine of C is going to be 12/13. Cosine of C is 5/13, and then tangent of C is going to be 12/5. Now, what if I give you something like number 2? I didn't give you the value of the hypotenuse, so you're going to have to sort that out. Go to Pythagorean's theorem, and I'm just going to call this little y. So we know c squared equals a squared plus b squared. That's your Pythagorean's theorem. Now for c, I have little y, so y squared equals 9 squared plus 12 squared. So y squared is going to be 225, so then y equals 15. So once I know that, I can then write my ratios. So from angle W, here's opposite, here's adjacent, here's hypotenuse. So sine of W is going to be 12/15. Now don't leave it like that, reduce it please. So this will be 3/5, 4/5. Cosine of W is 9/15, which equals 3/5. Tangent of W is going to be 12/9, and that's 4/3. I also want to point out to you, do you notice how 9, 12, and 15 are all whole numbers? And the same thing in example 1, we had all whole numbers. If you've got a right triangle and the sides are all whole numbers, that's called a Pythagorean triple. And if you can recognize a Pythagorean triple, then you don't have to actually do Pythagorean's theorem. And the most famous one is 3, 4, 5. And then any multiples of 3, 4, 5. So look at number 2. If you multiply 3 by 3, you get 9. Multiply 4 by 3, you get 12. Multiply 5 by 3, you get 15. So that's a Pythagorean triple. All right, so now we're going to start using these ratios to find missing sides. So take a look at number 1. We want to find x, and all I have is the hypotenuse and an angle. So you can't use Pythagorean's theorem because you don't have two sides. But what you can do is use our trig ratios. So Sohcahtoa. Also, check your calculator. You need to be in degree mode. Here's how you check it. So notice right here, it says radian. That's the wrong mode. And if I run in radian mode, I'm going to get the wrong answers. So here's how you fix it. I'm going to press second. No, I'm sorry, not second. Just mode. And then I'm going to come down to 1, 2. See how my radian's flashing? I'm going to go over 1. Now degree is flashing, so I press enter. That puts me in degree mode. So let's quit out of this. And see, now it says degree. Another way to check this is go tangent, 45. Your answer should be 1. So if you have tangent of 45 equals 1, you're good to go. Your calculator is in degree mode. All right, so here's the process we're going to use to solve these types of problems. First thing you're going to do is label the triangle. So step 1, label. Step 2, you're going to choose a trig ratio. Step 3, write your equation. And step 4, solve. So, doing this problem here, number 1, step 1, label. Now my angle is 28 degrees. So opposite of the 28 is where my x is. This is opposite. I also have 19. That's opposite the right angle, so this is hypotenuse. So I have opposite and hypotenuse. So go to Sohcahtoa, who has opposite and hypotenuse? And the answer is sine. So I'm going to say sine of 28 equals, my opposite is x, hypotenuse is 19. So that right there, that's my equation. Now all I have to do is solve this. Notice x is in the numerator, and I'm dividing by 19. So all I have to do is multiply both sides by 19. The 19s cancel out, and I get x equals 19 times the sine of 28. Now, all you have to do is punch that in your calculator, and then that's it. So get your calculator. We're going to do 19 times the sine of 28. Hit enter, and my answer is 8.9. Now, when I'm solving for sides, I'm going to round to the nearest tenth. And I don't have any units, so this is done. 8.9. Let's take a look at number 3. Same process. Label. My angle is 21 degrees. 26 is opposite the right angle, so that's hypotenuse. The x is touching the angle, so it's adjacent. Now go to Sohcahtoa, who has adjacent and hypotenuse, and the answer is ka, or cosine. So cosine of 21 is going to equal adjacent over hypotenuse, x over 26. Solving for x, so I multiply both sides by 26. 26 is cancel. X equals 26 times the cosine of 21. Now I'm ready for calculator. I'm going to do 26 cosine of 21. So 26 times the cosine of 21, 24.3. All right. Take a look at number 5. Label your sides. Here's my angle. I have to go across to get to the 15, so that's opposite. And x is on the hypotenuse. So who has opposite and hypotenuse? Why, that is sine. So sine of 33 equals 15 over x. Now x is in the denominator this time. Okay, denominator. Do not multiply both sides by 15. You're always going to multiply by whatever is in the denominator. So in this case, it's x. Multiply both sides by x. Those go away. So then I have x times the sine of 33 equals 15. Now, sine of 33 is just a number. You can divide both sides by that number. And don't worry, your calculator can handle it. So x equals 15 over sine of 33. And notice what happened is they swapped positions. When we started, we had sine 33 equals x over 15. But now they just swapped positions. So now x equals 15 over sine of 33. Get your calculator. We're going to do 15 divided by sine of 33. 27.5. All right. Also very common to have word problems in trigonometry, and it's really important to draw a picture. So here we have Jake leaned a 12-foot ladder against the side of his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? So I'm going to draw myself a picture. Here's the house. Here's my ladder. So right here, I'm going to have a right angle between the ground and the side of the house. We're always going to assume a 90-degree angle. It says the angle formed by the ladder and the ground is 68. So this is 68. It says the ladder is 12 feet long. So this is 12. So there's our picture. And it says how far from the base of the house did he place the ladder? So that's down there, the distance from the bottom tip of the ladder to the house. It's x. All right, we're going to solve this just like a normal right triangle trig problem. If it helps, redraw the triangle. I'm going to highlight the triangle. So that's our triangle. Here's my 90-degree angle. That's x. This is 12. Once you've done that, it's just like the other problems we did. 68 goes in there. So label the triangle. This is adjacent. This is hypotenuse. Choose your trig function. Well, Sohcahtoa, opposite and hypotenuse go with ka or cosine. So cosine of 28 equals adjacent over hypotenuse, 12 over x. Now all I got to do to solve this is multiply both sides by 12. X equals 12 cosine of 28, and then calculator. $10.6. And my units are feet. Okay. Now the next idea is going the other way. We've been knowing about angles and finding sines. Finding the sides. Trigonometry lets you go the other way. We can tell you about sides and you can find angles. And it means using the inverse trig function, which are written like this. Sine with a -1, cosine with a -1, tangent with a -1. Those are all inverse trig functions. That means your side lengths go in and angle comes out. Side goes in and then angle comes out. Sohcahtoa still works. So in many ways, we're going to set this up just like what we did before. The difference is going to be what we do on our calculator. So take a look at number 1. My angle is x. Opposite from x is 15, so that's opposite. Opposite your 90 degree is 24, so that's hypotenuse. That means I'm going to choose sine. Now I don't know what my angle is, so this is going to be sine of x equals opposite over adjacent, 15 over 24. Now your temptation is going to be to try to divide by sine. Now x is not being multiplied. X is the input to the sine function. It's also a ratio and a function. So what you need to do is invert this. You need to use the inverse. Can't stress this enough. Inverse. Inverses. So what I'm going to do is I'm going to take the inverse sine of both sides. And the notation for that is sine, you put a little -1. And take the inverse sine of both sides. When you do that, what comes out on our left side is x, and our right side is the inverse sine of 15 over 24. I'm not even going to bother to simplify the 15 over 24, because what I need to do is put this in my calculator. So I'm going to grab my calculator. I'm doing the inverse sine of 15 over 24. So to get inverse, I press second and then press the sine button. Notice right here, I have sine to the -1. And I'm going to put in 15 over 24. That's all I have to do. Close my parentheses, press enter, and there's my answer. 38.6821 blah, blah, blah degrees. Now when we are finding an angle, I just want you to go to the nearest angle. So x is going to be 38.6, that rounds to 39. So 39 degrees. And that's all you have to do. The key to these is remembering to put it in your calculator and doing the inverse. Let's take a look at number 6. Okay, we have x. So we're solving for an angle. That means we need to use inverse. Across from that x is the 7, so this is opposite. Touching the x next to it is the 5. So this is adjacent. So go to Sohcahtoa, sine, cosine, tangent. And a tangent's the last one. So tangent of x equals opposite over adjacent, 7 over 5. Now what I'm going to do is, the only way to get the x out is to do an inverse tangent. So inverse tangent, inverse tangent. Make sure you do it to both sides. This is an equation. When I do an inverse tangent of a tangent, x comes out. Now I just calculator. Inverse tangent of 7 over 5. Second, press your tangent button. Notice inverse tangent shows up. 7 divided by 5. Close your parentheses. Enter. I get 54.4, so that rounds to 54 degrees. All right, that's it for today's lesson. Thank you for watching and have a great day.